Hello, in this lesson I'm going to go over parallelogram proof. Before we start the proof, let's kind of review what is a parallelogram first. We say in class we learned that a parallelogram is a quadrilateral in which both pair of opposite sides are congruent. That is opposite sides. Parallel. I mean, opposite sides are parallel. So that is the very basic definition. This is a definition of parallelogram. We also learned three theorems. We said if two sides are quadrilateral, both congruent and parallel, then the quadrilateral is a parallelogram. So that's first theorem. The second one says if both pair opposite sides are quadrilateral, both congruent, then a quadrilateral is parallelogram. And the third one we learned is that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here, before we actually move on to the exercise, let's try to understand what each one's saying. So the definition says, let me draw a little picture to demonstrate what it says. So the definition tells me if I have a quadrilateral has four sides. So if the quadrilateral where both pair opposite sides are parallel, what it's saying here, if I have opposite side, this side parallel to this side, and I also have this side and parallel to this side, opposite sides are parallel, then it's a parallelogram. That is a very basic the definition of parallelogram. Now the second one tells me if two sides are quadrilateral both congruent and parallel, so I want two sides and it both parallel and congruent. Let me highlight this one. That's the thing I'm talking about. So what it's saying here, if I have a quadrilateral, let me draw, this is a rectangle. Let me draw a parallelogram. So what this one, number two, we say both two sides. I only want two sides. If two sides are both congruent and parallel, so I'm talking about two sides. So let's say talk about this pair of sides are both congruent and parallel. Then I said that quadrilateral is a parallelogram. That's the second theorem. Now the third theorem. The first theorem, and the next one it says, let me draw it first. Oh, I mean to draw blue, no one highlight here. Okay, let me, so I have, if it says, okay, so this one tells me if both pairs are opposite sides of a quadrilateral congruent. So I want both pairs congruent. So I want the opposite sides congruent. So this is opposite side congruent to this, and this one congruent to this. So when a congruent again means they have equal length. So that will be a parallelogram. So this is the second theorem. Now the third theorem says if the diagonals of a quadrilateral bisect each other, a key word here is bisect. So bisecting means they cut each other equal length. The diagonal cut each in length. So then the quadrilateral is a parallelogram. So let's kind of draw a picture for that one as well. So what it's saying here is I have a, okay, let me, quadrilateral. And the quadrilateral has two diagonals. So let's draw the diagonals. So diagonals for one and the diagonals the other one. So what it's saying here, if the diagonal bisect each other means they cut each other in equal parts. So it means this one is congruent to this one. And this length here is equal to this length. Then it is a parallelogram. So all these things we learn, if we want to pull a parallelogram, we pick from one of those theorems. Now let's look at the exercise below. That's what we're trying to prove. So in this exercise here, we say we are given that AD, BC bisects each other at E. We need to prove that B, D, C is a parallelogram. So some of you could, wait a minute, isn't that just theorem 6.23 here? Can I just use that to prove it? So slow down here. So one common mistake that students do is, well, this is a theorem. Why can't I just use that theorem to prove it? Notice that we say in a proof, a theorem, the part after the if from previous lesson, we said the part after the if is your given, which is the diagonals bisect each other. If the diagonal bisect each other, well, we're given that. If part is a given, Then the then part is what we need to prove. So this exercise here is the proof of this theorem. It asks you to put this theorem here. So therefore, you cannot use this theorem to prove itself. So it's kind of like, let me give you a analogy. Let's say, Joyce, I am getting my driver license for the first time. I'm going to the DMV. So I need to prove my identity. So DMV tells me, say, hey, you can give me your passport, you can give me a birth certificate, or you can also give me your driver license. Well, the thing is, I'm applying for a driver license. I don't have a driver license. So if I tell DMV, say, hey, how about this? Give me a driver license. Then I'm gonna use that driver license to prove that I am Joyce Me. So, well, wait a minute. You telling me that you assume that you are Joyce Me, and then you use to get the driver license, and then you use the driver license to prove that you're Joyce Me. That doesn't make any sense here, doesn't it? Same thing here. Same thing as a proof. So I'm asking you to prove that this theorem can be used to show that a quadrilateral is a parallelogram. If I use 6.23 to prove this here, it's telling me that, wait, I'm assuming this is true first, and then I use that to prove it. So you can't do that. So we cannot use 6.23 to prove itself. So be very careful here. We cannot use the theorem to prove itself. Now, that means that leaves us to three choices. I can either use the definition to prove that is this theorem, which I need to show the opposite sides are parallel right here. Or I could also use theorem 6.21, which I need to show two sides of quadrilateral both congruent and parallel, which is this option over here. Right? So to prove that is a parallelogram, I either use one or two. So it's totally up to you which one to use. If I use the first one, I need to make sure opposite sides are parallel. That's what I need to show. If I use the second one, the theorem, then I need to show that one pair opposite side both parallel and congruent, then it's a parallelogram. So let's say for let's just say that we want to use the theorem 6.21 to prove that. Let's say we're going to use this one for the demonstration. So we're going to use that one. That means I'm going to have to show that wait, if I use the 6.21, well, I'm just saying, but two sides of quadrilateral both congruent and parallel, which is this one, then I will need to show that this is true, right? So that's 6.21. I need to show both parallel and congruent. This is true. Let's talk about this one. We haven't talked about that one here. What if I use 6.22 to prove it? If I use 6.22, I just need to show the opposite sides are congruent. Then I'm done. Then it's a parallelogram. So there's three approaches I could do. So I could use a definition. I could use theorem 6.21. I could use theorem 6.22. Here, again, I'm going to use 6.21 for demonstration. I'd like to show you something involving parallel. So let's do this theorem. Let's keep in mind what I want to show. So I want to show that one pair of opposite sides are both congruent and parallel. Then it's a parallelogram. That's my plan. Okay. So let's look at our theorem here. Keep in mind what we wanted. So I want to have one pair opposite sides of both congruent and parallel. So let's see what we have now. Let's make a plan. So in previous lesson, we said that to show a pair opposite, show like sides that congruent, we could prove that triangles are congruent first. So let's use the given, write down what we know. So okay, let's write it. So given says A, D, B, C bisect each other at E. Well, by definition of bisecting, keyword. Bisecting means you cut the segment into congruent parts or congruent segments. So I know that BE will be congruent to EC. Okay. I also know that AE will be congruent to DE. So I have two sides already. So from what I draw here, I can look at this triangle and say, well, they are congruent. So let's see. If I have this, then I could say, look at the top triangle here. I can show that the top and the bottom triangle are congruent because notice that I also have a vertical angle right here. Again, this is called vertical angle. When two lines intersect, we'll say whenever two lines intersect, the vertical angles are always congruent. So I have By looking at the picture here, I have side, angle, side. I have a side right here, and then the angle followed by the side over here. So by side, angle, side, I could say that the top triangle AEC and DEB are congruent. In the same idea, you could also say AEB and DEC are congruent. So I can do either way. Okay, so let's do it. I'm going to put the top triangle. Let's see what happens if I know the triangle congruent. So plan one, plan. Okay. Keep in mind what I wanted. I want opposite sides are congruent and parallel, then it's a parallelogram. So if I show that these two triangle AEC is congruent to triangle DEB, I'm going to do that by side, angle, side. Then I can say two triangles are congruent already. Remember, we learned that if two triangles are congruent, then corresponding parts are congruent. That means including corresponding angles and corresponding sides. Let's kind of mark what happened if I have congruent. If I have these two triangles are congruent already, notice that let me use a different color. I would have AC congruent to BD. One pair of congruent side already. That's what I wanted. I will have that. So once I get this, I say, well, I'm going to get AC congruent to BD. Or D. I can write DB, BD. Doesn't matter here, but I'm going to write in order. So AC, DB. Okay. Notice that the reason I can say AC congruent to BD because they are corresponding part here. Notice that in the congruent statement you wrote AC. AC is the first letter and last letter in the congruent statement in the first triangle, and DB is the first and last letter in the congruent statement. So the corresponding parts. So this is will be true by CPCTC. So that is the reason for it. Well, again, think about what we need to show. If I want to use the theorem 6.21, I need to show that both sides, one pair opposite sides are both congruent and parallel. Then it's a parallelogram. We showed that it's congruent already. Can we show that they're congruent? Let's look at, do I have a corresponding angle congruent here? Note that, let's look at another part here. Note that we have, if I have two lengths that parallel, let me mark it so you can see better. So essentially we have this side over here. Let's see, we have some sort of angle we could use. So if I have this side congruent to this side. And notice that this one here is the transversal C here. So if we have alternating interior angle here, a congruent, then I could say these two lines are parallel. Alternating interior angle congruent, two lines are parallel. So we learned that again. So two lines are cut it by transversal such in a way we have this relationship. Then we say these two lines are parallel. Now we have the line angles are congruent and lines parallel here. So I could just show that the two lines are parallel. So number 3, that means if I can show this angle over here, just for easy notation, let's call this angle 1, angle 2. If I can show angle 1 and angle 2 are congruent, angle 1 congruent to angle 2, and I know this is going to be true by CPCTC as well, corresponding parts of congruent triangle are congruent. It's same thing as ACB, ACE, or I can also say DBE, same as angle 1, angle 2. Okay. Now, if I have that, then I can say, well, yeah, I have parallel already. Then I can make the conclusion that AC is parallel to DB because they are alternating interior angle congruent, then lines are parallel. Alternating interior angle congruent. I can make the conclusion that the lines are parallel. Again, just a little note there. Again, in your plan, you don't have to be perfect. You could just marking down the thing that you wanted. So this is the plan. We're going to follow the plan and write the proof. Note that the one in red is what I want to get, right? I want to get congruent angle. I want to get congruent opposite corresponding side congruent. And I'm going to use to put the triangle congruent first. The two triangle AEC and then DEB. Now let's do it. So keep in mind, first thing, and follow the plan. So step 1, to put the triangle congruent, I need to show how side angle side. So I'm going to write down the given, that's going to give me two sides. So I say AD, I'm given the AD and BC bisect bisects each other at E, and that is given. Now, once I have the given, again, look, keep in mind what you want it. I want to get a side and an angle and side from the two triangles that plan the congruent, AEC, BDC. So we say by the idea of bisecting definition, again, whenever we see keyword here, look, think about definition. We say bisecting segments means they cut it into congruent parts. So from here, I could say AE, BE, so BE is congruent to CE. That's my side that I wanted. Okay, I'm going to check that off. I have that side already. I can also say AE is congruent to DE. Okay, oh, I'm going to check that off. That's not a side that I have. And this is true because we said that a segment bisectors, type of definition is segments bisector separates a segment into two congruent segments. Okay. Now look at it. Now I need an angle. We say we are planning to use the vertical angle on top and bottom here. So I could say angle number 3. I could say angle AEC is congruent to angle DEB. And number 3. And note that this is a vertical angle is a congruent. Again, notice a vertical angle is just two lines intersecting to form congruent angles. It has nothing to do with parallel lines and transversals. Okay, I see a lot of common mistake here. So we say this is vertical angles congruent. Let's write it out. We say if two lines intersect, then we can make the conclusion that vertical angles are congruent. Then the vertical angles form the vertical angles formed by those lines are congruent. Okay, so if two lines intersect, I can make conclusion vertical angle congruent. Now let's say I just check off this angle here that I wanted, which is have a side angle side, which is according to my picture, I have exactly side angle side. Okay, mark again side. This is the angle followed by the side. Okay, so side angle side. I'm done. I just had met the requirement for congruent triangles. So now I make the conclusion. Number 4. I'm my step here. So I can say triangle. That's what I try to show in step 1. AEC is congruent to triangle DEB. Okay, and number 4 again. If this is by side angle side. Now I look at my plan again. My goal is to get this AC both and BD both congruent and parallel. So from here we could say using a marking angle 1, angle 2 are congruent, the corresponding angles. I can also say angle ACE. Let me write it. Number 5. Angle ACE. I'm using 3 letters here. Is congruent to the other angle DBE. Angle DBE. You can also, if you mark in your picture, you can also say angle 1 congruent angle 2. They're the same thing. Here, okay, it's right in different forms. So number 5, we say this is true by if two triangles are congruent, then corresponding parts are congruent, which is called corresponding parts of congruent triangles are congruent, which is called CPCTC. Okay, number 6. Now, notice that instead of writing down a step, I could say another conclusion. We said that if we can also make the conclusion now using that, we say, well, AC is also congruent to DB by CPCTC. But before I write that, I will jump to 3. So let's just do the 3 first. So number 6, I could make the conclusion that AC is parallel to DB. Okay, 6. Well, we said if alternating interior angles are congruent, then the lines are parallel. The line that form those angles are parallel. So say if the two lines, let's write it short, right? Let's write it short. Alternating interior angles are congruent. Let me write it short. Okay, then the lines that form those angles, lines, let me just form those angles parallel. Now let's check what we wanted. We want to show both sides of one pair opposite sides both are congruent and parallel. Well, we showed the parallel already. We haven't write a congruent yet because that was in part 2 here. We didn't write. So I'm going to write it down, add it in. So I'll say AC is parallel to BD. We should write this step before that actually. So number 7, I could say AC is also congruent to DB. For here, so okay, DB number 7, and we said this is a part. No, remember that ACBD are parts of the triangle that are congruent. So this is also true by CPCTC. Okay, so now we have both parallel and congruent, one opposite sides of a quadrilateral, parallel and congruent. Therefore, I can make the conclusion that ABDC is a parallelogram. So number A, I could say A, B, C. Is it A and B? Let me write in order. A, B, D, C. Maybe it's important here. D, C. Make sure each consecutive letter is a side. Is a parallelogram. Okay. Number A, we said we use this theorem on top over here. We say if but two sides of quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. That is 6.21 here, so I don't have to write a theorem again. This is theorem 6.21. Make sure you write it out. It's always good practice to write it out. Let me write it out. So we say if one pair of opposite sides okay, are both parallel and congruent, both parallel and congruent, then I can make the conclusion that the quadrilateral is a parallelogram. Okay. Let me zoom it in so you can see the whole proof. Okay. Again, when you do a proof here, make a plan. Always make a plan. Look at what you have and what you need. And which theorem, what are you using to do the proof? So once you make the plan out here, your proof is, writing the proof is matter of following the plan. Okay, thank you for watching the video. I'll see you next time.